Here in 10.5, the title doesn't look like we're continuing what we talked about in section 10.4. 10.4 was technically about dividing, and 10.5 is technically about adding and subtracting. So it feels like, if you're looking at the table of contents, it feels like you're talking about a different topic. But realistically, we're still talking about rationalizing the denominator. But we hesitate for a second and we talk a little bit about adding and subtracting, which honestly will be easy, but because we have to use that when we're talking about our more advanced rationalizing the denominator problems. So first of all, the rule for adding and subtracting is pretty simple. Simplify the roots and collect like terms. So if you were doing a problem like this top one here, the root here would have to be simplified. 27 breaks up 9 times 3. X to the fourth has a nice root, but y doesn't. So square root of 9 would be 3. Square root of x to the fourth would be x squared. Remember, you don't need absolute values there because that's already going to be positive. And if you compare the two components we have of this sort of a polynomial thing, you'll realize they're like terms. The only difference between them is the coefficient. This one has a coefficient of 3, that one has a coefficient of 5. Other than that, they're identical. X squared, square root of 3y. So 3 minus 5 of them, you get negative 2 x squared square root of 3y. The next one, though, has a very, very slight difference. I mean, the simplifying of the root works out the same. I won't even bother going through the steps because it's the same steps. But when you compare the two of them, they're not like terms. This has an x squared, that does not. And that's all it takes to make two terms not like terms. Any difference other than the coefficient can be different, but other than the coefficient, everything else has to match, otherwise they are not like terms. So simplify roots, collect like terms, be careful about like terms, but honestly you probably won't make mistakes about that very often. You're probably pretty good at like terms. A slightly more advanced situation would be something like this, where there's adding and subtracting and also multiplying, but I suspect you know how to approach this problem, where you've got basically two terms there times basically two terms there. I bet you're thinking of the FOIL method. First outside, inside, last. And I'm going to work it really slowly here in the video. Please feel free to skip a lot of the steps that I'm about to do. I'm doing things to where if you're watching the video later on, you can catch every little step in case you're missing something. So first means 4 square root of 3 times square root of 3. The first term there times the first term there. Outside, we have a positive times a negative. 4 root 3 times 5 root 2. Inside, we have positive times a positive, so it's square root of 2 times square root of 3. And positive times negative, square root of 2 times 5 root 2. So a lot of those you could have probably multiplied in your head. Some of them you might need to write out slowly like I'm doing here. Square root of 3 times square root of 3. Maybe you don't need to write square root of 9. Maybe you can skip right to square root of 9 is 3. It might be ambitious to go all the way from the beginning down to just plain 12, but who knows? Maybe you're really good at the arithmetic and you could have gone straight from first times first and written 12 on your paper. Here, for this one, 4 times 5 is 20. Square root of 3 times square root of 2 is square root of 6. But that doesn't really simplify any further, so it's just 20 square root of 6. Same idea here. Square root of 2 times square root of 3 is square root of 6. You might be seeing something else we can do in a second, but hold on, we'll get to that. And then here, the square root of 2 times the square root of 2 technically makes square root of 4, but you and I both know that that's 2, and 5 times 2 is 10. When you're foiling out problems like this, it's kind of common to end up with like terms in funny places. Like you'll notice, not only do we have like terms in the middle, yeah, negative 20 root 6 plus root 6 is negative 19 root 6, but you've also got like terms at the front and the end. 12 minus 10 is 2. So keep your eyes open for like terms in funny places, but for the most part, even these advanced problems, you're just sort of foiling things out. Here's why we're learning it. We are learning it to be able to handle rationalizing the denominator problems like this. And here's the key difficulty. Our denominator does not have just one term. Our denominator has two terms. It's not 3 root 2. That would be a fairly easy case. It's 3 minus root 2, and that makes two terms, and that makes things a lot harder. And in case you're not sure why that's difficult, let me show you what would happen if you tried to deal with this the way we dealt with things in 10.4. And this is really important. Sometimes students learn one technique and they just don't learn the later techniques, and they end up wrong because it's not quite as simple as they thought in the beginning. Here, if you just use 10.4's technique, where you simply multiply by the root in the top and bottom, that worked in the past, but it doesn't work here. 7 root 2 in the top. And here in the denominator, here's the thing that people forget. This needs to get distributed to both of these. You multiply the entire denominator. You don't get to pick and choose. I want to multiply just this one part of the denominator. No, you got to multiply the whole denominator. And square root of 2 times 3, and square root of 2 times square root of 2, yeah, the square root of 2 times the square root of 2 is square root of 4, which is 2. But notice there's still a root. In the denominator, that's not okay. So, quote, rationalize the denominator. We didn't rationalize the denominator. All we did was shuffle the root around and move it over to the other part rather than the second part. That didn't fix the problem we were trying to fix. So, let me show you what the correct path is. It is multiply top and bottom by something, but it's a more complicated something. And what you're going to need to remember here is something from Algebra 1. What I want you to remember is, oops, almost wrote the wrong thing there. Remember what happens when you multiply something like this. A minus b times a plus b. Remember how that goes? It's actually kind of a really nice simple situation. That ends up giving you a difference of squares. And here's what's important. If this is a and this is b, and I could just square a and just square b, I wouldn't end up with that mixed root thing that we had a second ago. So what I want to do here is I want to create that pattern. If this is a minus b, then what I need is a plus b. So the idea with these more difficult rationalize the denominator problems is what you need to do is you need to create a difference of squares so that in your denominator now you're going to have 3 squared, which will be 9, and you'll have square root of 2 squared, which will just be 2, and you won't have any roots in the denominator at all anymore. That's the whole point, remember. What we're trying to do is end up with a denominator without roots. Here our denominator is going to be just plain 7. Unfortunately, the numerator is not going to simplify any. It's just going to be 7 times 3 plus root 2. But just like we've seen in the past, yes, if there's reducing, you're expected to reduce. Those 7's cancel out, and you end up with an answer that's just 3 plus root 2. It doesn't always cancel like that in the end. That was just me showing you and reminding you that is something to watch out for. If that 7 there had been like a 5, then you wouldn't be able to cancel, and you would just either leave it as 5 times that or distribute it in. So let's do another example of that. You might want to pause the video, try it on your own piece of paper, and then press play again and see if you get the same answer I just got. Okay, so with this one, we're going to multiply top and bottom by something, and we're going to try to create a difference of squares. So in my mind, what I'm thinking is that the a part is the square root of 11, and the b part is the square root of 7, and I've currently got a plus b, so what I need is I need the a minus b part. Difference of squares has one with plus and one with minus. So what I need is square root of 11 minus square root of 7. So my denominator here is now going to be a squared minus b squared, which will be square root of 11 squared minus square root of 7 squared. The way I'm writing it here with parentheses squared, that's meant to help you avoid certain mistakes. A pretty common mistake is if people are trying to do this all in their head, they're mentally thinking square root of 11 squared, but all their brain does is 11 squared and they get 121. So if you write it out like this, hopefully it'll help you realize there's cancellation there. You don't get 121, you just get plain 11. Same thing here. This doesn't make 49, that just makes 7. So our denominator ends up being 4. Unfortunately, the numerator is nothing particularly nice here. If you take square root of 7 plus square root of 3 times square root of 11 minus square root of 7 and you FOIL it out, you're going to get square root of 77 minus, well, root 7 times root 7 is just 7. That part works out kind of okay. Inside is square root of 33, and last is square root of 21. 77, 33, 21, none of those simplify any. None of them are like terms with each other. There isn't really any sort of a rule about what order you're supposed to write them. Some people have certain habits, like some people will put all the roots last and all the numbers that aren't roots first, so they'd put this minus 7 in the front, but other people don't like to have minus signs in the front of everything, so they wouldn't do that. There is no rule about the proper order for those things, so really you just leave it whatever order you're happy with. So if you had those 4 parts in your numerator in some other order, you're fine. Absolutely nothing to worry about. If your denominator was something other than 4, though, you might want to go back and make sure you did all the steps right. This is the most difficult rationalize the denominator situation, where your denominator consists of 2 parts and you have to create a difference of squares. This is much more involved than what we did back in section 10.4.